Today's Leetcode problem of the day focuses on finding the k-radius subarray when given an array of length n and an integer k, in which k is the radius. We aim to find the subarray of the numbers centered for each index and using the radius k to determine the starting point of the subarray as I minus k and the ending point of the subarray as I plus k, including the two indexes. If there are less elements than before or after the index, an example would be when the radius would be out of range for the array, then the k-radius average is -1. We aim to return an array of averages for each index, where each average is a k-radius average for the subarray, which is centered at each index I. Each index value would be rounded down by removing the fractional part from the index value. An example is using the average of the four elements 2, 3, 1, and 5, in which the average value would be 2, truncated down from 2.75. An average is array of -1 for each value. The base case would be when the k is 0, in which the average would be the value at the index itself, so we will be returning just the array. Then we would initialize the length of the array as variable n and determine if the moving averages range 2 times k plus 1, which would be the lower bound plus the index of the element plus the upper bound, and compare them with the length of the array to check if the moving window is greater than the array length. If it is greater than the array length, the array will return the default value of an array of -1s. After determining the base case, we will determine the window sum as a sum of the number of the subarray of the window value and calculate its averages and assign them to index k. This is because we don't need to calculate the indexes before k, as before k the values would be smaller and out of range for the sliding window. For example, if you start at index 0, then you wouldn't have the window for the lower bound, as the lower bound value would be outside of the range of the array. Then moving on to the iteration, we would perform the moving window by subtracting the lower bound value, which is I subtract 2 times k plus 1 as the moving lower bound, and the numbers I would be the new upper bound value to show how the averages have shifted across the array. Using the sum, we aim to calculate the averages using the statement averages I minus k is an average of window sum divided by the number of elements, which is 2 times k plus 1 in the subarray. After using the moving window algorithm to shift through each element, we aim to return the result as averages.